In this video, we are going to be looking at standard form. Now, standard form is a way in which we can write really, really large numbers and really small numbers easily. Your calculator does this in standard form as well. Let's take, for example, the speed of light. Now, every second, light travels 300 million meters. Imagine you wanted to work out how far light would travel in a minute, an hour, a day, or a year. You can see that that number, which is 300 million meters every second, would get very, very large, and you'd end up writing loads and loads and loads of zeros forever. What we can do instead is we can use standard form. Now, standard form is often written like this: a times 10 to the power k. And what's important is that a is explicitly between 1 and 10. It can equal 1, but it must be less than 10. So, for example, it could be 3.9, 7.25, 8.41. Let's look at the speed of light, which is, as we said, 300 million meters every single second. Now, if I write 300 million, at the moment, the decimal point is here. But what I can do is I can effectively multiply 3 by 100 million. That would be the same as moving the decimal 1, 2, 3, 4, 5, 6, 7, 8 times. 100 million is 10 to the power 8. So what I can do is I can write this as 3 times 10 to the power 8. This is now in standard form. And you can see that 3 times 10 to the power of 8 is much, much easier than 300 million to deal with. Let's do another example. Let's say we've got 4,120. If we move the decimal point, we go 1, 2, 3 times. We could say, therefore, it is 4.12 times 10 to the power 3. All you have to do is count how many times the decimal point moves. Let's do another one. Let's take 32,000. Well, how many times does the decimal point move? At the moment, it's here. So we go 1, 2, 3, 4. So we would have 3.2 times 10 to the power 4. But what if you're dealing with a number that has a decimal point in the middle? Let's say we were dealing with 32.145. 32.145. Now, don't forget, standard form is a number which is between 1 and 10. So 32 is way too large. But if I move the decimal point once over, and I got 3.2145, that'd be just times 10 to the power 1, because I moved the decimal point just once. So that's how you write large numbers in standard form. What if we have really, really, really small numbers? Let's do it the other way around. Let's say we've got 0.000941. Well, where does the decimal point needs to go? It needs to go here. So I'm going to count how many times the decimal point moves, but this time it's going obviously the other way. So I go 1, 2, 3, 4. So it would be 9.41 times 10 to the power, and it's not going to be 4, because 10 to the power 4 means we're getting 10 to the power 4 times larger. We're getting 10,000 times larger. We're getting 10,000 times smaller, which is division. Now, think about your indices laws. When you're dividing, that's a negative power. So all I do is I write minus 4. We remember that divide by 10 is the same as timesing by 10 to the minus 1. Dividing by 100 is the same as timesing by 10 to the minus 2. And that explains why it's just going to be 10 to the minus 4. Let's have another example. 0.0000315. Again, the decimal point needs to be between the 3 and the 1, because then the number at the start is between 1 and 10. So then you know the decimal point has to go here. So like always, let's just count the number of times it moves. 1, 2, 3, 4, 5, 6, 7, 8. My answer is 3.15 times 10 to the minus 8. And that's how you write numbers in standard form. Let's just do 2 examples the other way around, where I give you standard form and I ask you to write them in numbers. Fortunately, this is really, really easy. let's say we had 3.28 times 10 to the power of 5 and 7.14 times 10 to the minus 4. Now, what we're going to do is we're going to add zeros in the correct places to start with. So because we're getting larger, we're just going to put zeros here. We're going to put as many zeros as we want. It doesn't matter. We haven't done anything to the number. The number is still 3.28. All the zeros in the end do nothing. Now, we're going to count 5 because that's how many times I'm moving the decimal place. And because it's times 10 to the power 5, I'm getting 5 times larger. Well, sorry, 10 times larger 5 times. 1, 2, 3, 4, 5. So my decimal point is going to go here. And the number, we just write it out, 0, 0, 0. You can put the decimal point in with the zeros on the end, but it doesn't matter. That's your final answer, 328,000. Let's do the same thing for the next one, 7.14. Now, I don't need the zeros on the right-hand side because I've got a minus 4 as the power. That means it's getting smaller. So I need to put all the zeros here instead. But you can see, actually, this doesn't make any difference either. I've still got 7.14. Wherever you put the zeros, it doesn't make any difference to the number. We're going to move it 4 times to the left. So I'm going to go 1, 2, 3, 4. And my decimal point will be there, 0.000714. And that's how you deal with standard form, both in large and small numbers, and also converting standard form to ordinary numbers.